Every single microscopic, perfectly silent gear operating inside a high-end luxury timepiece begins its life in absolute chaos. The Louis Vuitton Tambour takes that violent thermal energy and compresses it into a space barely a few millimeters wide. This piece operates as an automaton, a programmable mechanical computer designed to physically animate the dial. Shrinking this volume of machinery to a microscopic scale depends on the components surviving the same intense thermal energy used to create them. The specific sequence programmed into this dial replicates a traditional Japanese taiko drummer. A real-world taiko performance demands extreme kinetic energy. It requires massive booming drums and full bodily exertion from the musicians to generate a resonant sound. Historically, recreating human movements artificially required large, fragile clockwork hidden inside the torso of an antique doll. Capturing the kinetic energy of a taiko performance within a wristwatch requires metallurgical hardening precise enough to prevent the mechanism from destroying itself. The face of this watch is never touched by a paintbrush. It is forged using a technique called grand feu, or great fire, enameling. The process starts by taking raw, highly fragile glass powder and carefully layering it onto a microscopic metal disc. This chart maps the vitrification curve. Heat must spike precisely to 800 degrees Celsius to melt the powder seamlessly. The error margin is zero. Any temperature fluctuation or rapid cooling creates thermal tension that instantly shatters the piece. When you look at the pristine surface of the finished dial, you are actually looking at a physical record of the glass surviving intense thermal trauma. Beneath that static dial lies the hidden kinetic engine, an intricate network of microscopic gears and springs that will drive the drummer's movement. Driving an automaton generates intense physical friction. If these components were cut from standard microscopic metal, the sheer mechanical stress would grind the gears to dust in hours. The solution requires going back to the forge. The steel components are heat-tempered, a process that physically alters the metal's atomic structure. Precise blasts of heat wash over the components, hardening the steel and turning it a deep, tempered blue. This maximizes its wear resistance while keeping it light enough to be driven by a tiny coiled watch spring. The automaton's ability to smoothly animate on the wrist relies entirely on this invisible armor, locked away at the molecular level. From the chaotic 800-degree forge, the components are brought into the silent, sterile, room-temperature environment of the watchmaker's bench. Here, the durable, heat-tempered microgears must be painstakingly integrated with the fragile, vitrified enamel dial. This hyper-precise assembly is a direct continuation of Louis Vuitton's broader heritage of Savoir Faire. For generations, artisans have relied on tactile, manual manipulation to bend stubborn materials to their will. All the extreme thermodynamics applied in the forge would be entirely useless without the meticulous, cold calculation of human hands, bringing order to that raw chaos. The fully assembled Tambour Taiko Arty Automata sits perfectly still, a static portrait locked behind sapphire glass. Then comes the mechanical activation. The stored energy inside the tightly wound mainspring is finally released into the tempered gear train. The microscopic taiko drummer physically raises its arms, snapping downward and making contact as it strikes the drum. There are no screens or digital illusions here. Every motion is a physical chain reaction of mechanical parts functioning in real time. If you trace the kinetic energy of that tiny drummer's strike backward, through the gears and the mainspring, you find it is the direct offspring of those initial 800-degree flames. This is a mastery of thermodynamics, harnessing fire to engineer a silent, moving piece of art built to outlast its creator.